Okay, so we'll have a quick look at the graphical approach to all this. And we're going to look at what we call production possibility frontiers, PPFs, production possibility frontier. So what should that look like? I've already committed myself to something I don't like. I'll put a bit of scrap here. The first picture on the figure, that would be with, if we just had like x is ALL to the 1 minus alpha p to the alpha, where p is pollution, then you'd get something like this, where if for given labor and given productivity. And that doesn't make sense, right? Because pollution isn't an input. Okay. What makes more sense is something like this, or something like this. So I'm going a bit away from the picture here. So what's the difference? Let's start with this one. Here, if you have no, it's actually based on this function, but where does the resource come from? We have to send some final good to extract it, or we have to send some labor. Then you get this kind of picture. Okay, so if we don't send any labor to the resource sector, we don't get any resource input, we get no production and no pollution. But if we send all our final product Y to the resource sector and none to the household, then, so we send labor here, we make widgets, we send them all to extract the resource and make more widgets. Then we're here, right? We have no, so X would be this flow here. It's a bit odd. We should have it as a C, really, perhaps. Be clearer. But we can get to this point, maximize pollution and no consumption, if we just send everything round and round here. In between, there's some optimal, right, where we send just the right proportion here to maximize this. This case, there's some technology available to us that doesn't cause pollution at all. And that could be, for instance, an alternative technology. If this is coal, this could be wind, say. At least that might not be reasonable for pollution broadly defined, but if we think of specific pollutants one at a time, this is definitely reasonable. Okay, there's plenty of technologies available that don't cause sulfur emissions or don't cause carbon dioxide emissions. Okay, then the final picture in C, what happens as productivity increases? If we have this kind of function with this thing going on, this is for some level of productivity. If productivity increases, this moves out. Okay, and the same here. Okay, so then the question is, what happens to the choices? And basically, if we have, so this is for more general theories. Okay, if we have reasonable forms for the indifference curves where the marginal willingness to pay for pollution, dx dp, increases in x, so the more consumption we have for a given p, the more consumption we have, the steeper the slope of any indifference of the indifference curves have to be. Okay. So then if we extend that throughout, we get this kind of thing, right? So they have to look like in the picture A there. And they have to be convex. They have to have this curvature. So as P goes up, the willingness to pay also goes up. Okay. So when we put that together, then for low productivity, we basically just choose the maximum point. But as productivity rises, we start going this way, and that's not definitely going to happen if the PPFs go through this point. But if they don't go to the origin, then we will definitely hit the axis, and that's proved in their paper in the European Economic Review. We can also flip this picture. I did this after a lecture the other day with 2 or 3 of you. We can think of, okay, this is consumption, so I've replaced the X by a C now, naught. This is environmental quality, so this is perfect environmental quality. This is like pristine. This is zero consumption. This is environmental disaster if we're down here, right? The economy's collapsed. So when productivity is low, we sort of flip the PPFs and they look kind of like this. Okay? If we do nothing, we have perfect environmental quality and no consumption. If we just focus on destroying the environment, we have still a pretty good environment and no consumption. In between is our best choice. And then these move out. And if we go laissez-faire without any regulation, we have environmental disaster. And we would already be there. If you think of what was happening even towards 1900, first half of the 20th century in the UK, how dirty the cities were. Think of how dirty cities like Delhi are today, cities like Shanghai were 20 years ago. If we hadn't had policies, we would already have been choking to death on a massive scale. We are choking to death on a significant scale as it is. But instead, we have had policies which for many pollutants have taken us pretty close to here. For instance, for lead in the air. Okay. In the model with only one resource input and with this, the way we set it up, it turned out that you would go here, right? That you would end up with constant environmental quality and increasing consumption. But when we allowed for multiple resources and clean options, then we get like this. That's the model. What can we learn from it? I think I'm going to change the order of these slides a bit. So I think I'm going to stop there and I'm going to say, what can we learn from the model? So actually I'm going to redo these pictures a bit.